The fourth talk in this session is, as you can see, economic causal chain search and economic indicator prediction using textual data. Over to you. Please go ahead.
Thank you. Good morning. I'm Kiyoshi Izumi from the University of Tokyo. The title of this talk is Economic Causal Chain Search and Economic Indicator Prediction using Textual Data. As an introduction, I'd like to ask you two questions. First one is, what economic indicators will be affected by the spread of infection diseases? Second one is, what macroeconomic indicators are affected by the US presidential election? The answers of the first question is sales and profit margins of specific companies like condimented company and hotel business company. And guest room occupancy rate of the hotel is also be affected by the spread of infection diseases. The answer of the second question is the amount of foreign exchange and etc. To predict the change of economic indicators from the text, like infection diseases and presidential election, we developed the integrated method of natural language processing and statistical method. This method first constructs causal chain from the textual data. Secondly, this method finds economic indicators related to the words appeared in this causal chain using statistical method. I'd like to explain the first step of our method, causal chain search, using natural language processing. You can try our demonstration system of causal chain search from our website. When the user enters the text, the system shows the related cause and effects. The causal chain can be extended for the causality associated with the clicked node. Creation of economic causality database and causal chain search system consists of these three steps. This system, we extracted causal relationships from the text of financial statements in Japanese. Listed companies regularly publish to disclose their business performance and financial statements in this document. Over 3,000 companies in Japan regularly publish to this document to disclose their business performance and financial status. And the document includes many cause and effect expressions. We identified sentences that include cause-effect expressions from Japanese financial statements summaries using a support beta machine. Our approach uses the input features shown in this table to extract causal sentences. We employ both syntactic and semantic features. For example, clue expressions means frequently used expressions in causality sentences, such as due to or because. We trained support vector machine model using the annotation data with the information about whether each sentence includes causality information or not. Now we are developing more sophisticated method using financial Japanese BART model, and we can improve the accuracy of the identification. About the sentences contains causality information, we employed a syntactic method to extract cause-effect expressions from the sentences. After the dependency analysis and syntactic pattern matching, we identified the location of cause expressions and effect expressions in each sentence, and stored cause and effect expressions into the Causality database. Our economic causality database have over 1 million cause and effect pairs. To construct causal chains, our method connects an effect expression of a cause and effect pair and a cause expression of another pair. To do so, we used cosine similarity between embedded representations of cause and effect phrases. The system finds the most similar causalities from the database and added them to the causal chain. By repeating these steps for each effect expression of new node, we can extend the causal chain starting from the input text. This method can be applied to both the forward search and backward search. In the forward search, the causal chain built in order of cause and effect. A user can find the spillover effect of input text. The backward search makes a causal chain in effect and cause order, and the user can find remote causes of input text. After the construction of causal chain, our method finds related economic indicators as the spillover effect of input text or remote causes of input text. Our method predicts that the related economic indicators will change as the effect of input text. For example, infectious diseases may change the guest room occupancy rate of the hotel. To find related economic indicators, we use statistical method using other economic textual data provided by the company Deep Data Research. Deep Data Research gathering monthly corporate reports published on the official homepages. The data volume is more than 150,000. To estimate the strength of relationship between a specific word and economic indicator, we used adjusted odds ratio. Odds ratio is a statistical measure that compares the probability of event occurring in two groups. In this study, we compare the probability of occurrence of a particular word W in comments about indicator I with the probability of occurrence of the word W in all comments. If the odds ratio is high, it indicates that the occurrence of the word W is concentrated in the particular indicator I. In this experiment, we calculate the adjusted odds ratios of frequent words for each indicator. The text infectious diseases was given to the causal chain search, and the causal information was extracted, repeating the spillover effect of multiple layers. Then the economic indicators related to the causal information were predicted using our proposed method. The causal information of the second layer in the causal chain search and the top 5 economic indicators that are predicted to be strongly related to the causal information is shown. Furthermore, among these economic indicators, the numerical change of the room occupancy rate is shown in this graph. The transition of guest room occupancy rate decreased sharply around May 2020, when the lockdown was announced in Japan due to the spread of COVID-19. Since the numerical values fluctuate more than usual, it is considered that the predicted related economic indicators are strongly related to the causal information that spill over from infectious diseases. In the second case, the text US presidential election was given to the causal chain search, and the second layer of the causal chain contains words such as yen depreciation, high stock prices, economy, and boom. The top three economic indicators that are predicted to be strongly related to the causal information are shown. Among the related indicators, the numerical change of amount of foreign exchange is shown in this graph. The amount of foreign exchange rose sharply during both presidential elections in November 2016 and November 2020. The text global warming was given to the causal chain search, and the words greenhouse gas emission reduction target appeared in the causal chain. The top three indicators are shown here. Reflecting the growing concern about global warming, CO2 reduction is on an upward trend over the long term. In the final case, we inputted the text Olympics into the causal chain search system. And there are two such periods. Firstly, we constructed causal chain using textual data in 2016, and then we constructed causal chain using the textual data in 2020. In 2016, the Rio de Janeiro Olympics was held. The extracted words are golf industry, revitalization, and expectation. These results show the spillover effect of the new addition of golf as a new Olympic sport. The economic indicators predicted from the causal information were number of stores, number of customers, unit price per customer, and number of stores opened. In the case of Tokyo Olympics 2020, the causal chain contains words such as development project, construction period, review, and postponement. These results show the effect of COVID-19 and the postponement of Tokyo Olympic Games. The related economic indicators were number of stores closed and occupancy rate. This slide shows a summary of this research. That's the end of my presentation. If you have an interest in our work, please contact us. Thank you so much.
Thank you very much.
Thank you very much. So we'll leave the QR code there for Mo's just scanning that. Did you get it? Yeah. Thanks very much. So I see there's a couple of questions already from Jochen. I don't know whether you can see the chat. So Jochen says, thanks for an interesting talk. I like the causal search engine. Have you thought about how the causal chains extracted can be used by humans? For example, as part of a collaboration of people studying what is going on, they may need to edit to remove machine errors and insert human causality hypothesis based on their knowledge to supplement what the machine found.
Thank you. So in this our demonstration system, users can edit the causal chain, and we can incorporate the human knowledge in this system. Then we can use a log, user log of delete the node or change or something like that. Then we can cooperate with the users in this demo system. Thank you.
Domo arigato.
Thank you so much.
Thanks, Jochen. Did you want to follow up on your second point about the diagrams there?
Oh, this was just a link I found because there are these system diagrams in sociology. You increase one thing, you increase another thing. So it's and it's a nice way to create these. So I really like this work, and it could be applied wherever people are investigating something. Perhaps also investigative journalism, could be interesting, right? So your system may discover relationships that people may want to write about. So I think a natural extension of your work, which I much like, is to find out which of these connections are obvious and already known to everybody, and which ones are maybe more obscure and therefore interesting to humans. So I think this is a wonderful way to complement human work with machine work. So thank you very much for your presentation.
Thank you. Thank you for this information. So that's very interesting. And so as I said, so we want to incorporate the knowledge graph, handmade it. So that's my future work. Thank you.
Okay, thank you. So I see you're getting some applause there in the chat as well. I had a question about the causal chain work as well. Are you always focusing on a link within one sentence, or can your system go beyond the sentence boundary? I mean, for example, I was thinking of previous work that Mo, Steve, and I did on attribution. So quite often that refers, or you need to refer to the previous or maybe even the following sentence to find that link, to find where people are talking about what the attribution is of a particular positive or negative sentiment. I wonder if the same was true of your causal chains.
Okay, thank you. So our method can extract the causal information from the two sentences, up to two sentences. But so our method still cannot extract causal information from the very apart two sentences, so very close to. Anyway, so we now improving our method using the BART, so we can it's a huge work. Thank you.
Okay, great. Yeah, I guess that increases the complexity quite a lot if you have to start going beyond 2 and 3 and 4 sentences back. Okay, I see you've posted a link in there to something. Do you want to? Is that to your online demo? Oh, sorry, that was Mo. Oh, that was from the QR code. Yeah.
Yeah, that's our page, laboratory page. Yeah, thank you very much.
Mo has a question for you.
But as I said, yeah.
Sorry, just try to avoid the echo. Thanks a lot for that. If I want to try the tools, because I pasted the link because I think the demos are available in Japanese.
Now, this system is written only in Japanese now, but we now extend our system in other languages. Also in English and Chinese.
Sorry.
Sorry, we're just getting. We're getting echo.
Sorry, we were having difficulty. Can you please repeat the answer?
Okay. So now our system is written only in Japanese, but now we are developing an English version and Chinese version of my system. Thank you.
And my last question is, do you know of any is there a Japanese annual reports? Because we tried to contact the, I think it was the reporting council, the Financial Reporting Council in Japan, in order to see if there's a way to get annual reports. I wonder if you in research come across this.
So yeah, so we have a contact with the Bank of Japan and other financial institutes. So we are now incorporating other Japanese financial texts added to this document.
Okay. Do you mind in the future if we get in touch with you about
Yeah,
this?
please
Okay,
contact
well,
us.
I appreciate that. Thanks a lot. Very interesting.
Thank you very much.
Okay, thanks, Mo. And thanks, Kiyoshi. We'll give you a round of applause here.
Thank you very much.
Thank you very much.